All right. Hey there, Algebra 2 students, and welcome back to Ms. McGuire's classroom. So today we are going to be doing Unit 1, Lesson 2. And this is just a reminder that if you did not print out the guided notes in the that are provided for you in the blank copies of the guided notes folder on Schoology, and you are doing your notes on either notebook paper or graph paper, you just need to make sure that your notes are clearly labeled. Make sure you have Unit 1, Lesson 2 at the top. Make sure you have the topic and objective labeled. And don't forget to put your first and last name in that upper right-hand corner. And just keep your notes neat and organized because you will be submitting a picture of them later this week. So today's topic of our lesson is going to be focused on solving inequalities and interval notation. So we're actually going to be talking about two things: solving inequalities and interval notation. Now, both of these things should be a review from Algebra 1, which is good news for you. You're not really learning anything new. So hopefully, it goes as smooth and as easy as possible. So the objective today, what you are going to be learning, and what you should be able to do by the end of this lesson is, I will be able to solve inequalities graph the final answer, and write the solution set in interval notation. Let's go ahead and jump into example 1. So in example 1, you see that we have -3 times 2x minus 5 plus 1 is greater than or equal to 4. So the nice thing about inequalities is they're a lot like equations, in that we solve them the same way. So you're going to treat that inequality sign just like you would an equation sign. So our first step actually needs to be to distribute this -3. So -3 times 2x, -3 times 5, and then we can combine like terms. So -6x plus 16 is greater than or equal to 4. Then we need to subtract the 16 to both sides. So -6x is greater than or equal to -12. Now here is where inequalities differ from equations. We're going to have to divide both sides by a -6. Whenever you divide an inequality by a negative on both sides, you have to flip the inequality sign. So because I'm dividing this side by -6 and this side by -6, I'm going to flip my inequality sign. So then x has to be less than or equal to 2. So another way that inequalities are different from equations is that there is more than one answer in this solution. So x can be less than or equal to 2. That means that x could be 2, x could be 1.999999999, x could be 0, x could be -1,000, x can be any number that is less than or equal to 2. So we have multiple solutions. We have a solution set. So x can be any value that is less than or equal to 2. So how do we graph that? Well, we graph it on a number line to show and model the solution set. The graph on the number line just makes it obvious as to what x can and can't be. So to set up your graph, you're going to want 0, you're going to want some positive numbers, and you're going to want some negative numbers. Then you're going to put a circle on the value that x starts at. So x can be less than or equal to 2. So I'm going to put a circle on 2. Now, because x can be less than or equal to 2, that means 2 is included in the solution set. So I want to fill that circle in. I want a closed circle. And that closed circle means that 2 is included. So I'm just going to make a note of that for myself so I don't forget. The closed circle means 2 is included. All right. So x can be less than or equal to 2. Well, all the numbers that are less than 2 are to the left of 2. So I'm going to put an arrow that goes to the left of 2. I want all the numbers to the left of 2. All the numbers that are less than 2 are included in my solution set. So anytime you have less than or equal to or greater than or equal to, you're going to have a closed circle. So now let's talk about what interval notation is. So interval notation is another way to represent the solution set. It tells us what x can and can't be. So whenever you represent a solution set with interval notation, you want to make sure that you describe what's happening to the left first, and then you describe what's happening to the right. So with interval notation, we're going to describe what's happening to the left. So the left of this number line is headed towards the negative infinity direction. So to the left, we're going to negative infinity. To the right, this graph approaches and stops at 2. Well, with interval notation, we also need to use either parentheses or brackets. So we're going to use either parentheses or brackets. Parentheses mean not included, and brackets mean included. So because that 2 is included in our solution set, we're going to put a bracket here. And because negative infinity is a number that you approach but can't actually reach, you use parentheses whenever you have infinity in your interval notation. So our interval notation is negative infinity to 2. That's how we would read that. Negative infinity to 2. Our solution was x is less than or equal to 2, and then this is what that solution looks like on the graph or a number line. So according to this inequality, x is less than or equal to 2. What is a value that x can be? So why don't you go ahead and write like 3 examples of values that x can be according to this inequality, the graph, and the interval notation. So 3 numbers that you might have written down are 0, maybe you wrote down 2, maybe you wrote down negative 10, maybe you wrote down negative 0.999, maybe you wrote down 1.99999, and you can actually put like an infinite number of 9s here. This is still approaching 2, but not quite 2, right? So that's close as we can get to 2. Numbers that can't be included would be like 3, 4, 5, 2.00001. Those numbers can't be included because they're definitely not less than or equal to 2. So what I'd actually like you to do for example 2 is I want you to pause the video and I want you to get started on example 2 on your own and see how far you can get. I want you to try to completely solve the inequality. You need to solve for y this time. I want you to try to graph it and write your answer in interval notation, and then write some values that x can be according to the inequality that you solve for and find. So go ahead and press pause, and then you'll press play when you're ready to double check your work. So your first step should have been to distribute the negative 2 Then combine like terms. Then you probably added the 13 to both sides. And then divided both sides by -2. And I just divided both sides by a negative and forgot to do something really important. When you divide both sides by a negative, or multiply both sides by a negative of an inequality, you have to flip the inequality sign. So we get y is less than or equal to -8 this time. So when we graph this, again, we're going to want 0. We're going to want some positives. We're going to want some negatives. So I'm just counting by 2s. We're going to put our circle on the -8. Now, because y is less than or equal to -8, we have a less than or equal to or greater than or equal to sign. That means that the number is included, and we want to put a closed circle. So when you get to some examples later on, and you have, for example, you might have greater than or less than, you're going to have an open circle because that means the number is not included in your solution set. So we have our -8, we have our closed circle. Y needs to be less than or equal to -8. So we want all the numbers less than -8, which are all the numbers, again, to the left of -8. Then for interval notation, we always describe what's happening to the left first, and then what's happening to the right. We use parentheses when the number is not included. We use brackets when the number is included. So for interval notation, to the left, our arrow is headed towards, or our y values, our solution set is headed towards the -infinity side. Then to the right, it stops at -8. It's a closed circle, so -8 is included. We want a bracket there. And then we want an open circle anytime we use infinity, because we're approaching infinity or -infinity, but we never actually reach it. Because if you think of the smallest number you can possibly think of, so like -1,000,000, well, subtract 1. Now you have -1,000,001. Subtract 1 again, subtract 1 again. So the smallest number you can think of, you can always subtract 1 and make it even smaller. So we're approaching that really small negative value, but we're never actually like reaching an end point. So what is a value that x can be according to the inequality? So some numbers that you might have wrote down are -8, -10, -8.000001, -1,000,000, and any number that is negative and smaller than -8. It's perfectly fine and is included on that interval. So let's move on to example 3. So in example 3, part A and B, some interesting things happen with these inequalities. So I'm going to walk you through example A, and then I want you to give example B a shot on your own. So example A, I'm going to go ahead and distribute this -2. I'm going to get -6x minus 2 is greater than -6x plus 7. I'm going to add 2 to both sides. I get -6x is greater than -6x plus 9. I'm going to add 6x to both sides. And something interesting is about to happen, because what's -6 plus 6x? -6x plus 6x. Well, our variable canceled on both sides. We no longer have a variable in this inequality. We just have 0 is greater than 9. Now, because the variables both canceled out, so both variables or all variables canceled, we have no variable left in this inequality. We need to think about what this inequality now says. It says 0 is greater than 9. Is that a true statement? Is 0 greater than 9? No, it's not. It is a false statement. So we're left with a false statement. Well, just like with equations, if both variables cancel and you're left with a false statement, what do you have? You have no solution. So your final answer is actually no solution. And on your number line, you can label it. So how do you graph no solution? Do we have anything to graph? No, we don't. So because there's nothing to graph, you're literally just going to leave your graph blank, your number line blank. And we have no interval notation here because there is no value that our variable can be. So your answer is just no solution. So why don't you go ahead and get started on part B on your own, pause the video, and then you're going to press play when you're ready to check your work. So your first step was probably distributing that 5. And you get 10x minus 15 minus 7x is less than or equal to 3x plus 8. If you combine your like terms, that 10x and that negative 7x, you get 3x minus 15 is less than or equal to 3x plus 8. If you subtract the 3x from both sides, you're going to be left with negative 15 is less than or equal to 8. Or some of you may have taken, and I'm going to come work down here for just a second. Some of you may have done 3x minus 15 is less than or equal to 3x plus 8. Maybe you added 15 to both sides, and you got 3x is less than or equal to 3x plus 23. Then you subtracted 3x to both sides, and you got 0 is less than or equal to 23. So either way, if you ended up with this statement, 0 is less than or equal to 23, or negative 15 is less than or equal to 8, the following steps are still going to be the same, regardless of which inequality you have as your answer. Well, because all the variables canceled out, what we need to ask ourselves is, do we have a true statement? Is that true? Is negative 15 less than or equal to 8? And if you did your steps this way, you're still asking yourself, is that true? Is 0 less than or equal to 23? Well, in both cases, negative 15 is less than or equal to 8, and 0 is less than or equal to 23. So we do have a true statement. So just like with the equations in our lesson 1, we learned that if all the variables cancel and you're left with a true statement, your final answer is infinitely many solutions. So we have infinitely many solutions. Now, infinitely many solutions can be graphed on the number line, and it can be written in interval notation. And let me show you why. So if you label your graph infinitely many solutions means that any number will make this inequality a true statement. Anything you plug in for x will make this inequality true. If you plug in 0, it'll work. If you plug in 0.5, it'll work. If you plug in 1.1, 2.9, 4.1, 5.5, 4, 3, 2, any number, any negative number as well. All of these numbers are solutions for this inequality. So that means the whole number line is your solution. So you're literally graphing the entire number line. So then how do I put this in interval notation? Well, remember, with interval notation, you describe what's happening to the left first. Well, to the left, this graph is headed towards negative infinity. And then you describe to the right. Well, to the right, this graph is headed towards positive infinity. And because we can't include negative infinity, we use a parenthesis. We can't include infinity, we use a parenthesis. All right, there we go. The next thing we're going to focus on today is something called and inequalities. and or inequalities. So I'm going to help you out with example 4A, and then I want you to do example 4B on your own. So example 4A is 7 is less than 2x plus 1, and 3x is less than or equal to 18. So in this case, both of these statements are part of our solution set. So we're going to solve each one as if they were their own inequality. So I'm going to subtract 1 to both sides in the first one, and I get 6 is less than 2x. I'm going to divide by 2, and I get 3 is less than x. For this one, I'm just going to divide both sides by 3, and I get x is less than or equal to 6. And don't forget the word and. So whatever word is in between, you're going to want to make sure that you carry down between here. So now we need to ask ourselves, can 3 be less than x? Or you can also write this as x is greater than 3, and x be less than or equal to 6. Can those two things be true at the same time? Can a number be bigger than 3 and less than or equal to 6 at the same time? And the answer is yes. So let me show you how to graph that. So you're going to have 0, 1, 2, 3, 4, 5, 6. Make sure you get some negatives as well. So you're going to have a circle on 3, and it's going to be open because 3 is not included this time. And then you're going to have x is less than or equal to 6. You're going to have a closed circle on 6. So you want all the numbers that are less than or equal to 6, and you want all the numbers that are bigger than 3. Well, do you see how that solution set overlaps right here in between them? That's your solution set. You need the solutions that make both statements true at the same time. So we actually don't want all the numbers that go past 3, and we don't want all the numbers that go past 6. Then for interval notation, what does this look like? Well, to the left, our graph stops at 3. To the right, our graph stops at 6. 3 is an open circle, so we don't want to include 3. 6 is a closed circle, so we want to include 6. So 3 gets a parenthesis and 6 gets a bracket. And that's it. So we have our solution set, we have our graph, and we have our interval notation. So why don't you go ahead and try part B on your own. You're going to press pause and then press play on the video when you're ready to check your work. So you should have solved for x for both of these inequalities. So you probably added 1 to both sides for the first one. So 6 is less than or equal to 3x. You probably divided both sides by 3 and got 2 is less than x. You probably divided both sides by 2 and got x is less than 6. And we want to carry the word and down in between. So what this says is that x has to be less than 2 and x has to be less than 6. Or sorry, x has to be greater than 2 and x has to be less than 6. So let's go ahead and label our number line. Then you should have put an open circle on 2 and an open circle on 6. And because you want all the numbers that are less than 6, but also all the numbers that are greater than 2, your solution set is what happens, all the numbers in between those two. Then for interval notation, you describe what's happening to the left. So the graph to the left stops at 2, and then to the right, it stops at 6. So then they're both open circles. No, wait, that's wrong. I bet you caught that mistake as I was going through this, huh? This says less than or equal to, so this should have had an equal to sign here. So then 2 should actually be a closed circle. I'm glad I caught that before I published this video. 2 should have been a closed circle, so we include it with a bracket. 6 is an open circle, so we have a parenthesis, which means that we're approaching 6, but we never actually reach it. So now let's look at the difference between that and or inequalities. So once again, we have two inequalities, but this time we have the word or in between. So we're going to go ahead and solve each inequality separately. So for this one, I just have to subtract 7 to both sides, and I get k is greater than or equal to -1. Or, and this one, I just have to subtract 8 to both sides. K is less than -5. Well, can a number be bigger than -1 and less than -5 at the same time? It can't, which is why we have to have the word or in between. So a number is either greater than -1 or less than -5, but both can't be true at the same time. So on an or graph, I'm going to go ahead and label it real quick. For an or graph, I'm going to put that closed circle on -1, but I want k to be greater than or equal to it. So all the numbers greater than -1 are off to the right. Then for -5, well, k is less than -5, so I'm going to have an open circle, and I want all the numbers that are less than -5 or to the left of -5. So for an or graph, you don't include the numbers in between -5 and -1 because -3 isn't greater than -1 and less than -5. So we can't use these numbers in between. Our solutions are all of these numbers. So for or inequalities, our interval notation gets a little tricky because we have this separate graph happening off to the left and this separate graph happening off to the right. So what we're going to end up needing is actually two different intervals that we join together. So let me show you how that works. So you want to write an interval for this part of the graph and this part of the graph. So we're going to describe what's happening here to the left first and then to the right. So to the left, it's headed towards -infinity. To the right, it stops at -5. We can't include -infinity. We can only approach it. We can't include -5. We can only approach it because it's an open circle. So what we're going to do is we're going to union that. We're going to use U for union with another interval notation that describes this part of the graph. Well, to the left of this graph, it stops at -1. And it has a closed circle, so we're going to use a bracket because it's included. And then off to the right, it goes towards +infinity, which we approach but can't actually reach, so we use a parenthesis. So or inequalities get two interval notations that are union together. This interval notation describes this part of the graph. And this interval notation describes this part of the graph. All right, so why don't you go ahead and press pause on the video and then press play when you're ready to check your answer. Give part B a shot on your own. So in part B, the first thing you should have done is you probably subtracted 3 to both sides. So 7W is greater than 8. Divide both sides by 7. W is greater than 8/7. For the other one, you probably added 1 to both sides. So 4W is less than -12. Divide both sides by 4. So W is less than -3. And you want to keep the word or in between. So can a number be bigger than 8/7 or less than -3 at the same time? No, which is why we need the or in there, because the number can either be greater than 8/7 or it can be less than -3, but both can't be true at the same time. So then when you graph this, so 0, 1, 2, 3, 4, 5. So you put an open circle on -3. W needs to be less than -3, so you're going off to the left. Then for W is greater than 8/7. So 8/7 is really 8 divided by 7, which is 1.14. So 8/7, sorry, I want that to go away. Give me a second. There we go. So 8/7 is really 1.14. So 8/7 is just after 1 on the number line. And it's an open circle. And then we want all the numbers that are bigger than 8/7. So then your interval notation, you want to describe what's happening on this in its own interval notation and what's happening with this in its own interval notation. So for this left side here, towards the left, the behavior is we're headed towards -infinity. And then towards the right, we stop at -3 with parentheses around both. We're going to union that with the description for this guy. And to the left, we stop at 8/7. And to the right, we're headed towards +infinity, the parentheses for both of those. Here we go. So on your homework, make sure that for each inequality, you include interval notation for each problem. The book doesn't give you that in the directions. So I'm going to find out if you really watched this video or not by whether or not you include interval notation for each problem on your homework. So make sure you do this part, the interval notation part, like we did for all of our example problems, for your homework as well. So you get extra practice with interval notation. And that's actually going to come in handy later when we start describing the end behavior of graphs when we move into two-dimension graphs. I hope you guys have a good day. I'll see you later.